Okay, so if you're gonna look closely at the standard form of an ellipse, what is different about the formula compared to what we studied in the past about, we studied ellipses before. What's different about the hyperbola formulas?
It's minus.
Yes, the minus is what's different. In an ellipse, it was positive, but that's not the case here. Okay, and you'll notice if you look, a squared is in the front on both of these. You can't just pick the biggest to be a. A is basically the positive, all right? So in here, a belongs to x, so the major axis in this case is x, okay? It's not dependent upon which is bigger. And over here, a belongs to which axis? The y, okay? It's dependent upon which one leads. That's the difference between the two. Right, now, here's another couple things that are different. So go ahead and highlight that part. A squared is always the first value. That's critical. Right. Now, the next thing that was important is that, remember before, what did we do with a squared and b squared in order to find c? Do we add them or subtract them? Yeah, you subtract it. So that's another part that's changed. If you want to find c, you add a and b. So before we subtracted, now we're adding. So those are the two main parts that are different. Okay? Now the next thing you'll notice is that this parabola opens left and right, and this parabola opens up and down. How do you think you decide which direction it's going to open? The major axis. You look here. This is the major axis, is x, so in other words, it opens on the x-axis. So this opens left and right. Right? It starts with x, so it's open about the x-axis. See here? The x-axis is where it's open on. But this one starts with y, okay, and it opens, what do you think? With the y, so instead of left and right, what's it gonna do? Which way does it open?
Up and down.
Up and down. It opens up and down instead. Okay, so those are the biggest differences. So let's just get started and try one. If you look here, this vertice and this slope are the two things that are added to what we didn't have before. Okay? Guys, why did we add the vertice? Well, because before we just, we didn't label the vertice, they were just the endpoints. Okay, but now it's the actual edge of your graph. So you have to label them. The center of this graph is 0, 0. We talked about before that in a hyperbola, a squared is always what? Not the biggest, but what? First. Okay, so in other words, a squared then is 9. It's not the biggest. So this is a squared. So this is b squared. So then a, we're going to come down here like we've done before, is we're going to move left and right, how much? 3 units. Which direction, guys? On which axis? The x. And b, we're going to look over the y. We're going to do left and right. The square root of 25 is 5. On which axis? The y. Okay? Now, to find C, why do we need C? What's C? The distance between the center and the what? Foci. So C belongs up here at foci, plus or minus C. Okay? And we're going to decide, it's different than before. Instead of subtracting, you take a squared plus b squared. So 9 plus 25, c squared is the square root of 34. I'm sorry, c is 34. C squared is 34, so c is the square root of 34. You can't simplify that, so we're just going to leave it. And that is approximately, in your calculator, 5.8. So you know how many how many units to move. Okay. Now, sometimes a parabola, and I'll show you two examples right here. You can have a parabola, for example, this is the x-axis is the major, and it can be really skinny if you take two parabolas for your hyperbola. Okay, or I could make my hyperbolas much wider, right? Okay, and in order to know how wide or skinny to make it, you're guided by the slope. Where does slope come from? Change in y over change in what? X. Change in y over change in x. So that's why I have a little blank down here for slope. So slope is y over x. Okay, and we know how far are we moving x and y. We're moving 3 on the x and how much on the y? 5. So my slope then is 5/3. And guys, that's going to tell me how wide or skinny my hyperbola is. Okay, so the slope is 5/3. And you go both directions. So let me show you what I'm talking about by that. So let's graph our picture. Our picture starts at 0, 0. And our slope is 5/3. So you're gonna make a box around it. You're gonna go in every direction. Up 5, right 3, up 5, left 3, and then down 5. And then down 5, right 3, down 5, left 3. Right? And it creates, and if you'll go back and look at this picture above here, it gives you your asymptotes, okay? The slope of your asymptotes is here. And see how that just told you how wide to make your graph. That's what they're for. So you're gonna make yourself just a dashed X with those values. If that doesn't help us any as far as, well, okay, do they open up and down or left and right? But you know they open left and right because you lead with x squared. That's how you know. Okay? So let's find our foci and our vertices. If we start with our foci, we've already decided that our major axis is x. So when we build our points here for our foci, there's 2. If we're sliding our foci, if we're using C, because that's how far we slide through the foci, on the x-axis, which value stays the same up here in the center? The x or the y? Right, we're sliding on the x-axis, so the y value stays the same. So the y value is 0, we're going to keep it 0. And then, in this case, x is what we're sliding, so we're going to do 0 plus root 34 and 0 minus root 34. So you're going to have positive and negative root 34. So let's create that over here on our picture then. Let's draw our foci. So and below it, it tells us where to go. On the x-axis, slide 5.8. So do that. Okay. Now, let's think about the vertice. The vertice, look at your picture that we drew a few minutes ago. Okay? And your vertex comes from how far you slid when it wasn't, before it was an ellipse, right? Okay, it's how far you slide on the major axis, which used to be the biggest, but now it's the one in front. So what value is these two things right here? These are now called, if you take away this line, these are your vertex, right, of your parabola. So the distance from the center to the vertex is how much?
3.
3. Or what value? A. Okay. Right, so on here, the distance of A is between here and here. This is A. Right? So, in other words, on the vertice, we're going to add and subtract A. Okay, so I'm going to go over and look at A. A is 3. We're going to slide 3 on the x-axis. So So 0 plus 3 is 3, and 0 minus 3 is negative 3.
Amazing.
Okay? So now on your vertice, or your vertex, you want the vertex of your hyperbolas, or your two parabolas that make the hyperbola. So you're going to slide over 3. 3 to the right and 3 to the left. Okay, that's your vertex. Because remember, you slid your foci outside of your ellipse. Just going to turn it out. Then it gives you this really wide parabola. On each side. So you now have a hyperbola.
So does it not touch the point?
Say that again.
Does it not touch the points right there that are on the?
Are you talking about the X?
Yeah.
Asymptotes? No, that guides it. That's like what draws how far it draws. You see, if I do more, they become skinny and they look different. The foci are here. Okay. She asked, what does the foci have to do with anything? That's a good question. The foci, if it's inside, basically, okay, I guess for me to explain it to you, if this were hyperbola, okay, I'm messing up my picture, but let me explain something. Okay, if this were an ellipse, my foci would be here, and a string would make it work. Okay? But if I slide those foci outside of my endpoints, right? Okay, if I slide my foci, I'm here now, right? So my string will not make an ellipse anymore. The reason for why do I need a foci, okay, is because the distance, if I use a string now, like I would make a circle, okay, I could tie a string to the foci and it would make this half. There's a relationship between every single point on here and the foci. Okay, if you're trying to calculate all the points, that's why the foci matters. Okay, and kind of like when we would need to find A, B, and C, if we didn't know C or if we didn't know A, we could use all 3 pieces to find information about it. It's just a relationship. Before in a ellipse, we needed the distance of the major, we needed the distance of the minor. It was nice and pretty, and you could make an ellipse. We don't have that information. It's a different figure. They've slid them out so far that now then everything revolves around it going the other direction. Okay, it's just a little more abstract, but the idea is still there. Is a good question. Okay, now let's go to the back. Number 2. Okay, in this case, remember there's a minus here. So you're looking at the lead, it's an ellipse. So the first one is always A. So this is A squared and this is B squared. What's my center? 0, 0 again. Okay? And now then A then would be plus and minus 6 on the y-axis. This time the major axis is y. It's going to open up and down instead. It's going to go towards the y-axis. B would be plus and minus 2, and it belongs to the x-axis. C is the distance from the center to the foci. In other words, how far do they drag that foci out from the center? Okay, the farther they drag it, right? Okay, the skinnier or more narrow, it just depends on which way they go with each one. So this belongs to y, and to find c, we're going to take c squared equals, and we add them now. 36 plus 4. A squared plus b squared. So c squared is 40. So c is the square root of 40, which reduces to 2 root 10. So on the y-axis, to get to the foci from the center, you can go 2 root 10, which is approximately 6.3. So you're going to slide from the center 6.3 to get to the foci. Okay? Now remember, the foci is plus and minus c, but the vertex is plus and minus what? How do I get to the vertex? Do I use A, B, or C to get to the vertex? A. It's the length of, it's on the minor axis, the distance from the center to, I'm sorry, the major, the distance from the center to the end point. Okay? It's right here. Distance from the center to the vertex is A. Distance from the center all the way to the foci is C. okay? Right, so we can write plus or minus a here if you want. Okay, now, the slope is y over x, so 6 over 2, which is 3 over 1. Right, change y over change x. 6 divided by 2, 3 over 1. Okay, now start with graphing. Center is 0, 0. And let's make our asymptotes, our x. We're gonna go up 3 over 1 in every direction, make that box. The box is so tiny, it's hard to count. Okay, do you have an X? Now build this. Okay, this just guides your hyperbola, guys. Now, this X is a lot skinnier, isn't it? So my hyperbola, if it was opening on the X-axis, would be really wide and fat. But because it's opening on the Y, it means it's going to be really narrow. Do you see how we need the slope to decide? Okay, it kind of guides us to make the hyperbola. But we can't really graph the hyperbola until we know, okay, how far up do we go and how far down do we go? In other words, where does the hyperbola start? Okay, well that's a distance from the center to A. Okay, in this case, A was 6. How do we decide? Do we add 6 to the Y or the X? You look underneath here. We decided it was the Y value. Okay, so if you want to find the foci or the vertex first. If you want to find the vertex first, okay, then you make your 2 points, and we're sliding on the Y, so the X stays the same. And how much are we sliding on the Y-axis? A, how much is A? 6. So 0 plus 6 is 6, and 0 minus 6 is negative 6. So on the Y-axis, you're going to go up and down 6. And that's your vertex. Okay? Now, that means we know our graph is going to look like this. But they want us to mark the foci as well. In other words, how far do they drag the foci out? The foci is C, so we went 6.3. Okay? So you're going to add 6.3 to the Y value. So 0, 2 root 10, and 0, negative 2 root 10. So you go 6.3 in each direction. Mark my foci, I think it's too high. It's almost right next to it. And sometimes it's far away, sometimes it's close, it depends on how skinny they stretched it. Okay, we're gonna skip 3 and go to 4. Okay, on number 4,